Hey guys, okay, so I know that some of us are struggling with going from percent composition to empirical formula and then to molecular formula. So Ms. Herman and I decided that we are going to give you another worksheet so that you can practice these skills. I will download it as a PDF. This is what you'll see in your assignment. I am going to be recording this video so that you can watch me walk through the first problem with you. And then again, both of us have office hours, so please feel free to reach out if you need some more clarification. Totally happy to answer any issues. All right, so let's take a look at this very first problem. All right, Lanes, ready? Okay, so I want this blank sheet, so you gotta stand up so you can see the entire thing, so they can watch me work it. Okay? Can you see my hand? All right, so the very first problem says, what is the empirical formula of a molecule containing 65.6% carbon, 5.5% hydrogen, and 29% oxygen? All right, so these percentages we're essentially going to convert into grams. So the very first one says 65.5% carbon, okay, and then it says 5.5% hydrogen, and then we have 29.0% oxygen. All right, so now, like I said, we can pretty much convert that into grams. So if we're going to convert the percentages into grams, this is going to equate to 65.5 grams of carbon, 5.5 grams of hydrogen, and then 29.0 grams of oxygen. All right, let's hope we got to that first step. Now that we have grams, oh, I said grams. When I say grams, where do we go? To the periodic table. All right, so now that we're at the periodic table, we need to figure out moles. All right, so we have to figure out how many moles we have of each of these elements. All right, so I have 65.5 grams of carbon, and I know that, and I'm going to set up my train tracks here. I'm going to put 65.5 grams of carbon, and I know that in 1 mole of carbon, there are 12.01 grams. Where did I get that, you say? Well, I got it right here on the periodic table. If you just look at that mass quantity right there for carbon, 1 mole is 12.01 grams, and that is a conversion factor. Okay, so back to the problem. My grams of carbon cancel out. I'm at moles. Perfect. Then go ahead and you run the math. And hang on, I got to get my calculator out of the drawer. Sorry, a little unprepared. All right. All right, so go ahead and run the math. You've got 65.5 divided by 12.01. That ends up giving us 5.45 moles of carbon. All right, so now we need to do the very next thing with hydrogen. All right, so with hydrogen, we have 5.5 grams of hydrogen. And I know that 1 mole of hydrogen has a mass of 1.008 grams of hydrogen. Oh, Mrs. Van Gundy, I'm lost. How did you get that number? Oh, look here. Right here on the periodic table, 1 mole of hydrogen has a mass of 1.008 grams. That's where I got it. Remember, if I say grams or mass, you go to the periodic table. It's going to involve that molar mass ratio. All right. So grams cancels out, moles comes through. It looks like I've got it set up right. I'm going to go ahead and run the math. So 5.5 divided by 1.008 equals 5.46 moles of hydrogen. Very similar to my carbon number. All right, so this is for hydrogen. This is for carbon. Hey, honey, I'm recording a video right now. Just give me a second. All right, now this is for oxygen. So oxygen, we have 29.0 grams of oxygen, and I know that in 1 mole of oxygen, it's going to have a mass of 16.0 grams. Again, I got that from the periodic table. All right, so my grams cancel, my moles come through, so I'm going to go ahead and run the math. So 29.0 divided by 16, nice, and can you see that, Lainey? Okay. Equals 1.81 moles of oxygen. All right, cool. Now that I have these molar quantities, now what I need to do is I need to figure out which one's the smallest. So these two are pretty much equivalent. This one is 1.81. This is my smaller molar value. So now I need to take all of these molar values and divide them by the smallest molar value. So I'm going to come over here and do this with a different color. So next step is to divide by smallest mole value. Okay, so for carbon we have 5.45 moles, and I'm going to take that divided by the 1.81 moles. You asked where I got that from. I got it from over here where I got my molar values. Remember, this was the smallest one, that 1.81. All right, so if I take 5.45 divided by 1.81, all right, that gets me pretty close to a whole number, 3.011. So that's pretty much 0. We're gonna say, or sorry, 0, that's 3, okay? All right, hydrogen, we had that molar value of 5.46. Oh, I predict that this is gonna be very close to what carbon was. And you're gonna take that divided by 1.81. And we're gonna get the same answer pretty much. All right, you're gonna get 3.02 in this case, but again, that's very close to that whole number of 3. All right, and then for the last one for oxygen, it's gonna be 1.81 divided by 1.81. Lainey, what do we get when we do that?
1.
1, yep. 1. Okay, so now we can get our empirical formula. Okay, this is our empirical formula for covalent compounds. So that means we have 3 carbons, 3 hydrogens, and 1 oxygen. So the way we're going to write this out is C3H3O. Okay, all right, so now we have the empirical formula. This is the empirical formula. Hang on a second, guys. My son has a question for me. Okay, how can I help you? Here it is, right here. You go click on the video. There you go. Okay. Archie, you need to go downstairs with that, okay? Okay. All right, so now that we have the empirical formula, now we have to go to the molecular formula. All right, so it says, oh, never mind. It just asked for empirical formula, so we are done. All right. That is how you would solve the first problem. Okay, Lainey, I'm gonna need you, don't pause it, just keep it going. We're gonna do another one now where you have to take that empirical formula and make it into a molecular formula. So, are your arms okay? They're gonna fall off?
They're sore.
They're sore, okay. All right, so this is question number 1. Let me get another sheet of paper. We're gonna go over another one that'll lead us to molecular formula, okay? All right, so here we are. Now this is so this one right here, this was number 1. So this was number 1. Can you see that whole thing, Lainey? Number 1, did you get over it? All right, that was number 1. Now we're gonna work on, this is number 5. Okay? All right, can you see where I'm working? You don't need to hold it so far away, so you gotta see what I'm writing. All right, so at number 5, a compound with an empirical formula of C2OH4, and that's the empirical formula, and has a molar mass of 88 grams per mole. So that means we've got 88 grams per mole. So this is my empirical formula, and this is the molar mass. All right, so what I'm going to do is, very first thing I'm going to do is I'm going to calculate the mass of, the molar mass of this empirical formula right here. So I know that carbon is 12.01 times 2, because we have 2 carbons here, right? 12.01 was that number that I got from the periodic table. All right, oxygen has a mass of 16.00, and there's only 1 oxygen here. All right, and then hydrogen has a mass of 1.008, and we have 4 of them. So what we're going to do is we are going to add all of these up together. So I'm going to go ahead, I'm going to take parentheses 12.01 times 2 plus 16 plus 1.008 times 4 equals 44.052 grams per mole for the empirical formula. All right, and then I have 88 grams per mole. So what I need to do then is I need to take this 88 grams per mole right here, because this is the molar mass of the compound that they have. So I take that 88 grams per mole, and that looks weird when I set it up that way. So I'm going to take that 88 grams per mole, and I'm going to divide it by the 44.05. Just going to go to the 100th here, because that's all our scales can go to. And when I do that, 88 divided by 44, we're going to get 2, right? So 88 divided by 44.05 equals 1.998, which is 2. Okay, 1.998, and that equals 2. Very close to 2. All right, so that means that we need to increase our empirical formula by an order of 2. And since, if you go back up here, Lainey, to this empirical formula, we have C2OH4. We need to increase everything by 2. So basically, we're going to take this whole thing, multiply it by 2. And when we do that, follow me down here, we're going to get C4O2H8. And this, my friends, is my molecular formula. All right, so that pretty much tells you how to do number 1 and number 5. Again, if you have any questions or concerns, make sure you get a hold of myself or Miss Herman during our office hours, and we are more than willing to give you a little hand. All right, you can flip it to me, Lance, if you want. Just hold it up like this. Boom. All right, have a great day. Hopefully that clarified 1 or 2 things. If not, get a hold of me. All right, bye-bye.